Hey everybody, Dr. Heldman here. How are you doing? Happy spring day. In this movie, what I want to talk about is some of the ways that AI growth and development is being expanded. Specifically, there's a protocol that you should know about, and so I want to discuss that today. This is not a comprehensive overview of AI and machine learning. It takes years and years and years to learn everything that's involved here, but this is an innovation that you should be aware of. So if you're thinking about getting into AI and machine learning, it's something that you can study and be prepared for. So let's get started. So I'm sure that it's not lost on you that AI is everything now. All of these big technological companies are pushing AI. We have AI-based laptops, AI-based search engines, things like that. Super popular. There's a lot to know. It's a huge subject. It's like cloud computing or programming. There's a lot that you have to know that goes into it. And there is actually a lot of statistical knowledge that you have to have in order to be able to determine what's happening within the system. There are tools and all kinds of things. But one of the things that has been lacking that has now been developed is a protocol. Now remember that a protocol is an agreed upon set of communication, some communication strategy that you and I agree on. For example, if you're Japanese and I'm an American and I want to greet you, I might say konnichiwa. That's a protocol. We agree to communicate together speaking Japanese or speaking English or what have you. So in this case now, a protocol has been invented that is specifically for use with AI, and it's called MCP. Let's talk about this and see what's involved. So now the problem with AI integration today is that we use what are called application programmer interfaces. What does that mean? Well, let's say that you're Microsoft and you've written Windows 11. And you want to be able to allow programmers to write code that interacts with Windows 11. So what you do is you expose part of the operating system. You create these functions, these methods, and ways of accessing the operating system that aren't going to damage the operating system, but that can get the job done that you want to be done. That's an API, and you have to consult APIs in order to be able to communicate with certain systems. And Windows isn't the only one. Of course, Apple has APIs and so forth. So there's a lot to this. What this means, though, with regard to AI, is that you have to custom code everything. There's no good way for these things to communicate together. There's a ton of models, a ton of different methodologies for getting AI going. And so in a lot of cases, the integration has to be custom coded. I've got an AI system. I want to communicate with your AI system. We've got to custom code some sort of an environment that links those together and gets done what we want to get done. What this means, and the word we use in coding is it's brittle. This means that things break with every single little update, or there's the potential for things to break. Now, it's also inefficient. It takes time and money to build out these complex integrations. Now in large AI data centers, and these things are starting to get tremendously large, this gets even worse because you have tens of thousands of models, agents, services, all trying to talk to each other. That's why MCP was born. So let's take a look at this and see what's involved here. First of all, you should be aware that these AI data centers are colossal. We're building hundreds of them all over the world. They are huge, huge environments. They're so large, they have tens of thousands of graphical processing units that are being used to run the AI code, the models and so forth. These are better than central processing units, CPUs, because there's a better way that they can actually do this AI faster, the machine learning faster. And so these data centers have tens of thousands of GPUs, racks of GPUs in them, and they consume an immense amount of power, to the point now where we are talking about building little miniature nuclear power plants next to each one of these data centers. In fact, I heard a stat just the other day. There's a proposal for, I think it's 63 or 65 nuclear power plants built in the United States alone by 2027, just to handle all of these AI data centers. So it's a big thing, just in terms of how we're going to build these things out. But then, on top of that, you have the complexity of the code that's running these AI programs. So it's a big, big deal getting into AI and ML. There's a lot to know about it. Now, you should be aware we're talking about APIs. The conventional way of me using an API to talk to your machine or vice versa, there are two primary models. One is called the remote procedure call. This has been around a long time. In Windows, RPC is TCP port 135, but a remote procedure call can use other ports if it needs to. So that's one kind of technique that we use. Another kind is called representational state transfer. It's called the REST protocol. Both of these APIs use HTTP to access resources that are exposed by a server. So this is the idea. We're talking about client-server computing. We need to use an API to go in and query that server, get information out of it. And we're going to use, in the old days, with these APIs, we would use HTTP, Hypertext Transfer Protocol, to do that. Now you should know that with HTTP, the addressable entities are called data entities. They're called resources in the HTTP specification. So on the right-hand side of the screen, I show that to you. So if we're accessing through HTTP, we're going to use data entities. So we're passing data to the server. Here's something I need done. And then the behaviors, the methods, the functions, the thing that gets stuff done behind the scenes is called a procedure, and we can't see that. So it's called a behavior, and we can't see that. On the other hand, with RPC, over here on the left, RPC has procedures. There are things that we want to execute, and then out of that we get the data, and the two collectively communicate with each other. Now this comes out of an article, a good Google article that you should go read. I put the link down there for you. This is very interesting, but the main point that I'm trying to make with this slide is these APIs, they're still heavily in use. Don't get me wrong. I'm not saying that they've been deprecated or anything like that. I'm just saying that now this MPC is starting to take over this environment, because these APIs were at one time the only thing that was known about. Now we have something new to be able to facilitate that communication. Now it's important to keep in mind that in addition to that, there are three primary ways to use HTTP for APIs. So the concept here is, I'm a company, I'm going to write an API, I'm going to use HTTP to do that. Why? Because we get at it using a client-server methodology. So we go out and we get at a server and we do some work, and we do that using HTTP or HTTPS. There are three primary ways to do that. The REST protocol, which we've talked about. There's Google RPC, and in addition there's a company called Apache that's terrific in this environment, and their product is called Apache Thrift. And then there's OpenAPI, which is an open source API for this kind of work. However, you should be aware now that these things exist. They're being used every day by coders writing ML and AI code, but MCP was created to provide for a cleaner, more responsive, more far-reaching API that could work with a variety of AI models and tools. The concept is we want to get everything working together. This reminds me a little bit of networking back in the day, when a lot of different tech companies said, hey man, we need to hook all of these computers together, get them talking to each other. There were a variety of different protocols that were developed. NetWare had their protocol called IPX SPX. Banyan Vines had their protocol. Microsoft had their protocol. IBM had their protocol. And so everybody had a different way of doing things until finally, ultimately, what happened was Transmission Control Protocol, Internet Protocol, TCP/IP was invented, and everybody got on the same bandwagon, and the machines were able to communicate together. That feels a lot to me like what's happening here with MCP. People are like, okay, I can use these normal APIs like REST and gRPC and OpenAPI to get the AI doing what I want it to do, but there should be a cleaner, more universal method, and that's what we're thinking MCP is going to do for us. Now, MCP is not HTTP. Please do not make that mistake. It is a new protocol, and I've told you before that TCP/IP has thousands of protocols, and they keep inventing new protocols. This is a new one, and it stands for Multi-Agent Communication Protocol. Now, this word agent is an important word for you, because what it means is I've got a piece of software that's going to do some work for me with regard to the system that I'm interacting with. And these agents can be installed, like a lot of times you might get agent software that you install on a particular computer, and then that gives it the ability to communicate with another system. So this is agented. I would say that this is an agented system. It's an emerging open standard, so it's open source, way good, and it's designed to make AI systems talk to each other efficiently and securely. Now, this sounds really great, but you got to know that there's going to be a lot of going through different processes, finding different bugaboos, getting things working. This isn't going to immediately all knit together overnight, but people will continue to work on this, and ultimately it'll spin like a top. It'll be actually really, really good, but it's going to take some time to do this because of the very, very complex nature of what we're trying to accomplish here. Now, you can think of MCP as a universal translator for AI agents. So I've got an AI agent here that speaks Japanese. I'm speaking colloquially. I'm talking about languages as though they were the actual AI models. That's not what I'm just speaking colloquially. One of the AI agents speaks Japanese, the other one speaks English. Here's another one that speaks German, meaning they have their different ways of communicating. The translator for that will be this AI agent that allows that to happen, and MCP is projected to be the thing that'll do that. It's also a messaging system that allows models and services and tools to be able to collaborate without hard coding every interaction. Instead of accessing and coding for individual APIs, API stands for Application Programmer Interface. It's a way a programmer can get at a particular system and make it do things for them. Agents speak MCP. This is a common language for exchanging messages, commands, and knowledge. So this is really, really good, because what's happening is people are saying, hey, all this AI is out there, and it's all crazy. Everybody's doing their own thing, and we need to come up with a way that we can kind of merge these things together so they can talk to each other more efficiently. That's the point with MCP. Now, let's talk about the agents and the agent libraries. There are two slides here. An agent you can think of as an autonomous software component that can perform tasks, it can make decisions, and it can provide services. Autonomous means it functions by itself. In AI, this could be a chatbot, it could be a recommender, it could be a data retriever, it could be an image captioner. AWS has something that will convert languages. You get the idea. So that's what we've got. We've got an agent that's doing this work for us. Also, agent libraries provide reusable components. So you can think of them like AI logos, little things that you can put together to do a certain work for you. You can mix and match them using MCP. This matters because you can build very modular systems. Like, you can start out a little small. Like, you've probably at some point you've watched somebody build a doghouse, or you've seen a doghouse or a shed being built, and they start out kind of small. They build the floor and the walls, and then eventually they add on. It's very modular. So in this case, the agents are modular, they're reusable, they're interoperable AI systems, so we can put them together. And you can scale on top of that these AI services horizontally across data centers. I can tell you this is very, very exciting for big companies like Google and Microsoft and Amazon and others that have a large AI presence. They're very excited about this because they can have data centers all over the world that are able to talk to each other using these AI agents. You can also integrate different models. As you begin to study AI and ML, you'll find that there are different models that do different things, and using these agents we can incorporate those, put them together, and the services from different vendors or open source projects without fighting with the API. Now what does that mean? That means that if I'm going to write code for Windows 11, for example, I have to go get that API. Fortunately, they're online today. I have to know how those functions work, how to write the functions so that it accurately goes and does the work that I needed to do with the Windows 11 operating system. It's the same sort of idea. You have to know how the API works, and then you have to know how to write the code that's going to make it do what you want it to do. So MCP simplifies that. It provides what are called message schemas, meaning this is the way the message is going to go out, this is the way it's going to return back, roles and behaviors, and then with security standards built in. Sounds like a lot, doesn't it? Well, you should take comfort in knowing that there are a lot of very, very smart people all over the world working on this and assembling together in meetings and talking about how this might work. There are coders that are writing these things. So this is an endeavor that you should definitely keep an eye on, and maybe it's something that you get excited about and you want to know more about it and get more training on it. Now, why use MCP instead of traditional APIs? Well, first of all, we're talking about what is called context-aware communications. Agents have the ability to negotiate their roles, they can share a context with one another, and we can chain tasks. Can't do any of that with APIs, so we can get a lot more bang for the buck, if you'll excuse that colloquialism. We can get more work out of the system by utilizing these smart agents. Also, dynamic discovery, so agents can find and collaborate with new agents at runtime, so that's very interesting. Hey Bob, what you doing over there? You got something going? Can I help? Sort of idea. And then you can get what's called AI native orchestration, meaning instead of using an AI API that's meant to do this, I can use an agent API that will do something for workflows, multi-agent workflows. I can get these things talking to each other, and it's ideal for things like AI pipelines where I need to assemble something, do some work that's going to be longer, more involved than just a simple query, task decomposition to figure out how to do jobs, how to do things, and agent cooperation. So the bottom line here is that MCP lets you build flexible, intelligent systems that evolve without having to rewire the whole thing every time you add or change a model. That's the point. And the behindedness of this, if I could use that, the derriere of this is that AI is growing so rapidly, so quickly, and it's so huge and enormous. You know, we're talking about NVIDIA, who's one of the chief manufacturers of these GPUs. That's $1 trillion company now that has gone from making GPUs for game machines, and they still do that, to making GPUs that are used by the thousands in data centers specifically designed for AI. So this MCP thing was bound to happen. As I said before, we're in the early stages of assembling these things, getting them talking to each other. But just like TCP/IP, a lot of people have realized, hey, we need some standardized protocols that allow us to communicate within the boundaries of all of these different systems so we can get more work done out of them. Now, there is a career angle here. This is why MCP should be exciting for you. It's not just for developers, but for everyone who wants to work with AI systems integration, data center orchestration. You might find yourself, flying all over the world, setting up AI data centers. There are people that do that for a living. I work for one company where they would build, it wasn't a data center, it was a call center. They could build a brand new call center with 3,000 employees at the phones in 30 days. So it can get really, really clever and carried away and very highly mechanized. Also, intelligent infrastructures. So think about that term, intelligent infrastructure. That means not only are the AI models functioning together, now under the sheets you've got these agents that are talking to each other, facilitating some sort of an intelligent environment for these AI models to be better at what they're doing. Now, companies are going to need people who understand multi-agented systems. If you're coming out of the networking environment like Cisco, there are agents for different hardware and software platforms that are used there. This is the same sort of an idea. It's software that's going to act as an intelligent agent, and you have to know how that agent behaves. Also, you could deploy and manage MCP-based AI services. That might be something where you find a real attractive spot for yourself in the world of AI and ML. And you might learn how to build agent ecosystems using agent libraries and agent orchestration tools. If you're eyeing a career in AI infrastructure, DevOps for AI, AI systems engineering, MCP is the technology that you want to have in your brain and on your radar. You need to know about it. Now is the time to jump in and learn as much about it as you can. Now is the time to really dig in and do your research on this new protocol. Now, are you enjoying these videos? I hope you are. I love creating content for you guys. If you're liking these videos, please share them with others. Tell others about my channel. I'm trying to grow the channel. Really appreciate that. Like and subscribe. And you're welcome to drop comments. I get comments from you guys. I love them. They're always really positive. I super enjoy them. So thank you for that. And I will talk to you in the next movie. Have a great day.